Good day everyone. MCQs part 5. We are going to see chapter 1 relations and functions. In this part 5 let us see few sums in relations. Then in the next video part 6 we will see functions. Okay. Let A is equal to the set A comma B comma C. It contains 3 elements. Or is a relation defined by A comma A, B comma B, C comma C, A comma B. Now you have to find or is reflexive, identity, symmetric or equivalence. Hope you all remember what is reflexive, what is symmetric, what is transitive, what is equivalence. What is the difference between a reflexive relation and an identity relation? Okay. Now here if you see A comma A, B comma B, C comma C. These 3 are the reflexive pairs we call, right? Because we have 3 elements. For reflexivity we should definitely have A comma A, B comma B and C comma C. Now you have an extra element A comma B. But that doesn't matter. It is still reflexive. But here you should know the difference. Suppose you want it to be an identity relation, that extra element should not come there. It should contain only the reflexive pairs. That is the difference. Okay. Identity relation will contain only reflexive pairs. But reflexive relation can contain any extra element, but all the 3 reflexive pairs are there. So this is only reflexive. Is it clear to you? So now the option A is your correct answer. Now let us move on to sum number 2. Now the second sum. Let R be a relation defined by R is equal to x comma y such that 1 plus xy greater than 0, where all x comma y belongs to R. This R is relation, this R refers to real numbers, okay, is equivalence, reflexive and transitive but not symmetric, symmetric and transitive but not reflexive, reflexive and symmetric but not transitive. Now, before going into the sum, I want to say one general concept which you must know. That's very important. Whenever you want to prove something in maths, especially in relations and functions also, if you want to prove, generalize and prove. Don't just give an example and prove, because it may be true only for that example. Whereas if you want to disprove, you can just give an example, because if you are able to prove for that particular example it is not true, then you can just say that that property doesn't exist. Okay. So now here it is given 1 plus xy greater than 0 and that x and y belongs to real number. Now if it is reflexive, you know, I have to take that x and y both as some same letter x. So I can take, for reflexive it is 1 plus x squared. Instead of xy I will take x into x squared, right? Now you all know any square is always either 0 or greater than 0. You have a 1 plus. So definitely this is going to be greater than 0. So you can say R is reflexive, right? Now let us come to symmetric. That is, if 1 plus xy is greater than 0, that should imply 1 plus yx is greater than 0. You know, xy and yx, they are same, isn't it? Because multiplication is commutative. So when 1 plus xy is greater than 0, you can definitely say 1 plus yx is greater than 0. So R is symmetric. If we come to transitive, if I take the generalized way, how will I take? I know 1 plus xy greater than 0. Okay. 1 plus yz greater than 0. Now this should imply 1 plus xz greater than 0. But I can't find any generalization. I won't be able to say. Just because 1 plus xy is greater than 0 and 1 plus yz is greater than 0, I won't be sure that 1 plus xz whether it is greater than 0 or not. So here I want to take some example, and if I can disprove, then it will not be transitive. So now here I am going to take first minus 1 comma 0. That is, this is the x and that is the y. Okay. Now you know this is greater than 0 as per this relation, because this is x, this is y. So 1, okay, plus xy, that becomes 0. So this is going to be greater than 0. Then I am going to take here 0. So that y is z, I am going to take 0, 2. This is y, this is z, right? Now this I will check using this 1 plus y is z. So 1, because 0 and 2, 0 into 2 is 0. This is also greater than 0. So now I have got 1 plus xy greater than 0. I have got 1 plus yz greater than 0. So now I will check what happens to 1 plus xz. Now what is x now? Minus 1. What is z? 2. So I will get 1 minus 2, right? This is lesser than 0. So we are not getting 1 plus xz greater than 0. So here we are able to disprove it for one example. You can think of some other examples also. So we say this is not transitive. Is it clear? It is reflexive. It is symmetric, but it is not transitive because we have disproved it now. So let us check the options. Option D, reflexive and symmetric but not transitive, and that is your answer. Do you understand how to approach this sum? Now we will be seeing some formulae and concepts which are not given in NCERT textbook. I will tell you and we will do few sums based on them. Let me explain few concepts now. If set A has m elements and set B has n elements and the relation are such that A to B, that is relation goes from A to B, then the total number of relations, that will be equal to 2 power mn, m into n. The number of relations from A to A, if A has n elements, is in the same formula, both are n. So that will be 2 power n squared. Then the number of reflexive relations from A to A, if A has n elements, is equal to 2 power n squared minus n. The number of symmetric relations from A to A, if A has n elements, is equal to 2 power n into n plus 1 by 2. Please note down all these formulae in your notebook. Definitely this will help you to answer the MCQs. Actually one more is there, that is how to find the number of equivalence relations if the relation is from A to A and A has n elements. That I will teach you. It's a separate concept that is called Bell's triangle. That also I will teach you when the sum comes. Okay. So first copy down all these. Definitely these are very important. Now I will move on to the sum based on these concepts. Now let us see 3 sums based on the concepts. Now you have noted down. Okay, very straight formula application. Now see the third sum. Set A has 4 elements. Set B has 3 elements. Or that is the relation is from A to B. Number of relations is, now that you know the formula, what is the formula? 2 power m into n, 2 power mn, right? So here m is 4 and n is 3. So 2 power 12. That is your correct answer. So the option D is your correct answer. Once you know the formula, you can very easily do the sum, right? Now look at the fourth one. The relation is from A to A. A has 3 elements because it is A to A. Okay. Now the number of reflexive relations is, what is the formula for the number of reflexive relations? 2 power n squared minus n. Okay. Or you can write 2 power n into n minus 1 also. Both are same. Now what is n here? N is 3. So 2 power 3 squared is 9 minus 3. So 2 power 6. So that B is your correct option, right? So only thing is you need to know the formula, that's all. No more working. Now here see the fifth sum. Here also the relation is from A to A. A has 3 elements. The number of symmetric relations is, remember the formula for this? That is 2 power n into n plus 1 by 2. That is the formula. So now your n is 3. So it is 2 power 3 into n plus 1, that is 4 by 2. So it is 2 power 6. So it is option D. So these three sums are very straight sums. So learn the formulae well, then you will be able to do it. Okay. Let me tell you, what is belt triangle? The belt triangle is used to find the number of equivalence relations, right? If your set A has 1 element, 2 element, 3, 4, 5 like that, you can find the number of equivalence relations. Okay. Well, what you do is first write 1. Then below that you write another 1. Then that 1 plus 1 is 2 you write here. Then this last you write here. 2 plus 1 is 3 you write here. 3 plus 2 is 5, right? It will go on increasing, no? First 1 number, then 2, then 3 like that. Now write this 5 here. 5 plus 2 is 7. 7 plus 3 is 10. 10 plus 5 is 15. Now write the 15 here. 15 plus 5 is 20. 20 plus 7, 27. 27 plus 10, 37. 37 plus 15 is 52. So now, if n is equal to 1, the number of equivalence relations is 1. If n is equal to 2, it is 2. n is equal to 3, it is 5. n is equal to 4, it is 15. n is equal to 5, it is 52. You can go on like that, but normally they won't ask you beyond it. So this is enough, but this is a very easy way to find the number of equivalence relation. Now see this sum. Or such that A to A. A has 4 elements. Number of equivalence relations is, they have given 4 options. Now see, n is 4. So what do you have here? 15. So now your option C is the correct answer. So this is called belt triangle. Using this, you can actually find it. Okay. Let me explain what is an equivalence class. Okay. Now, let R be an equivalence relation on set A. That is, the equivalence class will exist only in an equivalence relation. I can say equivalence class is a subset of the equivalence relation. Okay. Now, if you take some element small a which belongs to the set A, then the set of elements X which belongs to A such that there are 2 things. That is, one is that X should belong to A and X should be related to A. That set of elements you call as equivalence class of A. You denote it by A and you put a square bracket. Okay. I will give you a simple example now. Now, A is 1, 2, 3. A is a set containing 3 elements. Now the relation R I am giving 1, 1, 2, 2, 3, 3, 2, 3, 3, 2. This is an equivalence relation. Now from this relation, I want to find the equivalence class of all the elements. That is element 1, 2 and 3. Now if you want to find the equivalence class of 1, you now take this. Here if you see, here the first element 1, there is no other 1 there. That 1 is related to 1 only. So the equivalence class of 1 is the set containing the element 1 only. Okay. If you see the equivalence class of 2, now this starts with 2, this also starts with 2. So now which element is related now? Here 2 and here 3. So this set containing 2, 3, that will be the equivalence class of 2. If you consider 3, you have 3 things, 2 sets here, 3, 3. So 3 is related, 2 is related. You can change the order, that doesn't matter. So this is equivalence class of 1, this is equivalence class of 2, this is equivalence class of 3, right? Now, one more property we should know is, these equivalence classes will be disjoint or they will be equal, they will be identical. See here, this is 2, 3, this is 2, 3. Or here it is 1. So A may be either disjoint or they may be identical or equal. Okay. Then if you find the union of all these things, you will definitely get the set A. The union of all the equivalence classes of all the elements, no, that should be equal to set A. Based on this, you may get a sum. This is for a single element. Like this for an ordered pair. Now we will see one sum. Now see this sum. A is equal to 2, 3, 4, etc. up to 80. the relation is A comma B related to C comma D. This is double implication. Implies and is implied by AD is equal to BC. This is the relation. The number of ordered pairs of the equivalence class of 3 comma 2 is. That is the question. That means this is one element because it is an ordered pair element. You have to take this as A comma B, right? Whatever is given, you take it as A comma B. In the single element, you take it as A. Here, you take it as A comma B. Now, you have to find the C comma D such that your AD will be equal to BC. That is the relation. Actually, because it is a multiplication here, see here, 3 comma 2, you can have the same 3 comma 2 as C comma D. Now, you see AD 3 into 2, 6, 2 into 3, 6, right? Then what you do? Multiply this by 2, multiply this by 2. You get 6 comma 4. So now 3 4s are 12, 2 6s are 12, right? Come to the next one. Multiply this by 3, multiply this by 3. Multiply this by 4, that by 4, 5, 6. Then we cannot have because up to 18 only a set is there. So now I have 1, 2, 3, 4, 5, 6 pairs of equivalent elements. So the number of ordered pairs I have the option C. Do you understand? If here it is multiplication, here also you have to multiply. If it is addition, you have to add here also. That is, find the difference and check that kind of terms there. Then it will be correct. Hope you have understood this. If you have any doubt or if you want any other sum to be explained, please write it in the comment section or you can contact me in WhatsApp in my number. It is 98414 24159. Definitely I will clear any of your doubts. Okay, whatever you want, please feel free to ask me. So in the next video, we will see functions. Thanks for watching the video. Subscribe to the channel if you have not yet done. Please share it with your friends and classmates if you like the video. Thank you.